Okay, we're going to do a little bit of exponent practice here as a follow-up to the Teaching Exponent Concepts video. If you feel like you want to try these problems before we go over them, pause the video and go ahead and do them, and then you can kind of check yourself and see if your answers were correct as we go through this. We do have this little note up here at the top, x to the 0 power, which stands for any number to the 0 power, and just as a reminder, that's equal to 1. And x to the first power, any number to the first power is that number. So in this case, since we're using a variable, any number to the first power is itself. The answer would be x. So in this case, we've got multiplication, the x for multiplication. In the other video, we had the dot. Either one is okay. They both mean multiply. This is actually a page from one of my units, and I just figured it'd be easier to put that on here and use it since it's already set up and ready to go. We're going to put these expressions into exponential form, which means put them into the form with the base and the exponent. So we've got 1, 2, 3, 4, 5, 6 threes. So that means 3 to the 6th power. And when we calculate 3 to the 6th power, we get 729. 5 times 5 times 5 is 5 to the 3rd power. And the value of that is 125. 5 times 5 is 25, times 5 again is 125. 1 times 1 times 1 times 1 times 1 is 1 to the 5th power. And no matter how many times we multiply 1 times 1 times 1 times 1, we're going to get 1. Now, this is a case where students may be tempted to make that little common error that we see where they multiply the exponent and the base and think 1 to the 5th power is 5. But if we carefully go through here and say 1 times 1 is 1, times 1 again is 1, times 1 again is 1, times 1 again is 1, and break that down so they can see that. 1, 2, 3, 10 to the 1, 2, 3, 4, 5, 6th power. And as we mentioned in the previous video, we can think about powers of 10. Our answer has the same number of zeros as the exponent. So 10 to the 6th is a 1 with 6 zeros, or a million. That's a big zero, sorry. There's only one 12 here, so that means it is 12 to the 1st power, which is equal to 12. Here we're writing the expressions with multiplication, so I believe that is 4 to the 5th, so we would have 4 times 4 times 4 times 4 times 4. 6 to the 3rd, that means we need 6 3 times. 6 times 6 times 6. And 10 to the 1st is just 110, so 10. All right, in this section, we are comparing these values. So 2 to the 8th or 4 to the 4th. Now, if a student makes that error where they just multiply the base and exponent, they're going to say these are equal. 2 times 8 is 16, 4 times 4 is 16. So if they say it's equal, we know that that is what mistake they made. However, 2 to the 8th is 256, and 4 to the 4th is also 256. So maybe they didn't make that mistake if they say that they're equal, but it would definitely be something to make them write down to make sure we've got 256 and not 16, and then talk about that. 3 to the 3rd power is 27. 9 squared is 81. So 9 squared is more than 3 cubed. Sometimes students will think that because the exponent is bigger, the number will be bigger. So we have to make sure that they're understanding we're getting our answer by multiplying 3 times 3 times 3. 6 to the 3rd power is 216. 216. And 10 to the 2nd power is 100. 10 squared is 100. So in this case, smaller number with a larger exponent is larger. Okay, over here we could do the same thing, exponential form. This is 4 to the 3rd. 4 to the 3rd is 64. 7 squared is 49. Oopsie, I was going to write 49 there. 7 squared, 49. 9 to the 4th. Anybody remember that from any other time? 9 to the 4th is 6,561. And then 1, 2, 3, 4, 5, 6 to the 5th is not 30. 7,776. Those numbers get pretty big pretty fast. 8 squared, and when we are writing with multiplication or kind of in an expanded form, is 8 times 8. 11 to the 4th, 11 times 11 times 11 times 11. 13 to the 3rd, 13 times 13 times 13. And then again, we're comparing. 7 to the 3rd is 343. And it looks like 2 to the 8th. 2 to the 8th is 256. We found that out earlier. So this is larger. 5 squared is 25. 2 to the 5th is 32. Again, here, if students say that these are equal, we know that they're doing 5 times 2 and 2 times 5. So we want to make sure they're not doing that. 6 to the 4th is 1,296. And then 12 squared is 144. So this one is larger. And then we have this last question here. Why isn't 3 to the 5th equal to 5 to the 3rd? Which value is greater? And again emphasizing for students that 3 to the 5th is not 15, 5 to the 3rd is not 15, so that they actually have to explain that, spell that out. 3 to the 5th is 243, and 5 to the 3rd is 125. So 3 to the 5th is greater. Okay, hopefully that was some good practice for you. Maybe you took some time to do this before we went through all the answers. If not, and you did it at the same time, hopefully we're all on the right track. We're all together. If you have any questions, let me know.